Today's lecture is on gamma garden. Under gamma garden, you'll see the characteristics or the salient features of gamma garden, then advantages and disadvantages. It is a form of a mutation breeding where the plants are exposed to radioactive sources, typically cobalt 16, in order to generate the mutations, some of which have turned out to be useful. Gamma garden is a type of induced mutation breeding where the radioactive source, particularly the cobalt 16 or cesium 137, are used to induce the desirable mutations in crop plants. The concept is popularized after World War II for peaceful use of atomic energy for the crop improvement. The first gamma garden was designed in a Long Island in USA. In India, first designed at Bose Research Institute at Kolkata in 1959. The second is constructed at Indian Agricultural Research Institute, that is the IARI, New Delhi in 1960. Characters of gamma garden. Gamma gardens are the area subjected to irradiations of crop plants. They are giant structures enclosed by thick, high wall to protect the plants and animals outside. The purpose of garden is to irradiate the whole plants during the different stages of development and of varying duration. The source of radiation used is a cobalt 16. Rarely, cesium 137 is also used as a source of radiation. The strength of cobalt 60 is 200 curies. The source of radiation is located at the center. The area is divided into concentric circles with varying intensity of radiations. Plants to be irradiated are arranged in a concentric circles around the radiation source. The intensity of radiations decreases as one move away from the source of radiations. The radially arranged plants in a garden can be grouped into three sectors. We'll see later on. This is the layout of gamma garden. That gamma garden, which is divided into three sectors. The sector first, the plants they are nearest to radiation source. Plants die immediately due to high dose of radiations. Plants not used for further experiments. In a sector second, the plants located next to sector first, these plants develop abnormalities. These plants are also not used in experiments. While in a sector third, the plants these are located next to sector second, they have a random mutations not serve to damage the plants. The variations obtained in the plants used for further breeding experiments, they are used as a source for hybridization or released as a new variety depends on desirability of characters and improvements. The radiation source, which is at the central region, advantages of gamma garden, generates the large variations within extremely in a short span of time. Wanted mutants can directly release as a new variety in a market. It is a very excellent example of peaceful use of atomic energy for human welfare. Then we'll see the disadvantages. The initial investment is high. Other cheapest mutation methods are now available. The chance of undesirable mutations are very high. The mutations are random. We cannot predict the effect of mutations. The loss of many natural good qualities of crop due to recessive mutations. The predictions of the mutations not a possibilities of the loss of desirable characters. Then due to segregation of the alleles in the next generation, the less stability of variety.